On the night of May 10th into May 11th, 2024, a camera trap array in the Appalachian foothills of North Carolina, one node in a nationwide standardized wildlife monitoring network, stopped recording at 2:14 a.m. local time and did not resume until 6:41 a.m. The station is part of a coordinated survey run out of institutions including the North Carolina Museum of Natural Sciences, using passive infrared trail cameras deployed on a fixed protocol. No cellular uplink, no shared network, each unit keeping its own internal clock, calibrated by hand at deployment, and checked only when a technician physically retrieves the card. What made this particular gap worth pulling out of routine data is what turned up when technicians compared logs across the wider network afterward. 6 other stations spread across Minnesota, Missouri, Colorado, Montana, and Washington State, 4 separate time zones, went dark within the same 8-minute window of local clock time that same night, each one resuming on its own separate schedule afterward, some within the hour, one not until the following evening. Picture the North Carolina site at that hour. Ridge fog settled into the hollow below the mount. No wind moving the rhododendron thick enough to trip a passive sensor. The kind of dead-still spring night this station's 4 prior years of data show producing almost no false triggers at all. This was not a battery failure. Every affected unit's power log shows continuous voltage through the gap, no drop consistent with a dying cell, and every unit resumed recording still running on the same battery that had been in it before the blackout. It was not a card error either. 5 of the 7 units used different card brands and firmware versions, ruling out a shared manufacturing fault. And it was not the kind of gap a scheduled diagnostic produces. None of these stations run on a synchronized maintenance cycle, and none had a diagnostic scheduled anywhere near that week. The detail nobody on the review team has been able to explain away is the clock itself. 7 independent units, 4 time zones, no shared network connection of any kind, landing within 8 minutes of each other on local time rather than on a single shared moment. 7 clocks that never talk to each other don't land on the same minute by accident. Where those 7 stations sit matters as much as what stopped happening inside them. The network they belong to is real and well documented. Snapshot USA, launched in 2019 by the Smithsonian Institution and the North Carolina Museum of Natural Sciences, is the only standardized camera trap survey with data from all 50 states, coordinating more than 200 partner institutions through a shared data platform called Wildlife Insights. In its first full survey year, the project logged over 166,000 wildlife detections across 1,509 camera sites and 110 separate arrays. Across its first 5 years of operation, the combined dataset grew to nearly 1 million recorded image sequences from 263 arrays nationwide. There is no single number for how many recording gaps a network this size logs in an ordinary year. Equipment fails constantly, in isolation, for mundane reasons, and nobody compiles a public tally of routine outages. What the network's own retrieval records do show, for this specific night, is 7 stations, 4 time zones, 1 shared 8-minute window on local clocks. It would be easy to file this as coincidence dressed up with a coincidence of timing. 7 cameras, 7 ordinary malfunctions, landing close together purely by chance across a country full of active stations. That explanation survives a casual glance at the calendar. It does not survive the fact that the same night, May 10th into May 11th, 2024, also produced the most intense geomagnetic storm the planet had experienced in over 2 decades. A G5 classified event, later named the Gannon Storm, driven by 8 X-class solar flares and at least 7 coronal mass ejections striking Earth within a 5-day window. It would also be easy to assume the storm explains everything on its own, simply because the dates line up. It does not, on its own technical terms. The Gannon storm's confirmed effects were on GPS and satellite-linked systems. GNSS position errors up to 70 meters, agricultural losses topping $500 million from GPS-guided farm equipment, high-frequency radio degradation, and induced currents in long-distance power transmission lines. None of that is the kind of interference a simple, offline, battery-powered infrared camera with no antenna and no satellite link is documented anywhere in the literature to experience. And a single physical event striking Earth's magnetosphere at one moment should register at the same instant in universal time across every affected station, not the same clock number, in 4 different local time zones, which is exactly what these 7 logs show instead. And it would be easy to assume 7 stations out of hundreds is too small a sample to mean anything at all. Set against a network logging results from roughly 260 arrays a year, with no other night on record producing anything comparable. 7 simultaneous local hour gaps on the single most extreme space weather night in 20 years is not the kind of thing this network's own baseline noise would be expected to produce by chance. The network these 7 stations belong to spans roughly 3.8 million square kilometers of combined survey territory across the continental United States, from Atlantic hardwood forest to Rocky Mountain alpine to Pacific temperate rainforest. Different ecosystems, different equipment technicians, different institutional oversight, with nothing connecting them administratively except the shared data standard every array reports through once a year. Understanding exactly how this network operates and why 7 scattered gaps eventually landed on the same desk matters before anything else about this file makes sense. Snapshot USA is coordinated by conservation biologists at the Smithsonian's National Zoo and Conservation Biology Institute and the North Carolina Museum of Natural Sciences, working with camera trap technicians at each partner institution who manage their own local arrays independently. Nobody on the coordinating side runs the individual stations day to day. The technicians who deploy and retrieve cameras in Missouri have never met the ones working the array in Washington State, and the 2 teams share nothing but a common data upload standard and a set of protocols for camera height, spacing, and deployment length. That structure is deliberate. The whole value of a standardized national network depends on hundreds of independent teams following the same rules without ever needing to coordinate directly. Each affected station was provisioned according to that same shared protocol. Units mounted roughly waist height on a fixed post or trunk, positioned along documented wildlife corridors, running continuously on battery power with no external connection of any kind, retrieved on a schedule set independently by each institution, typically every 4 to 12 weeks, depending on the array and the season. Some stations use game trail bait, others don't. Some run through winter, others are pulled before first snow. The only constant across all 7 is the reporting standard each institution uploads to at season's end. The retrieval that surfaced this pattern happened months apart at each site. On each institution's own schedule, North Carolina's card was pulled in June, Montana's not until September. Nothing about any single retrieval flagged anything unusual on its own. A multi-hour gap in one camera's log is background noise in a program logging results from hundreds of stations a year, most of which experience at least one unexplained interruption before the season ends. The pattern wasn't found in the field. It surfaced when a data manager working through the year's combined upload noticed the North Carolina gap's timestamp while cross-referencing metadata for an unrelated quality check, then ran a search across the full national dataset for any other station, reporting a gap opening within the same window of local time that same night. 6 more came back. From 4 different states the analyst had no reason to expect any connection to. What the review eventually cataloged from those 7 logs amounts to its own inventory, built the way any cross-network anomaly gets built once someone finally runs the comparison. The gap opening times themselves, 209, 211, 214, 215, 216, 217, and 2:17 a.m., each on its own station's local clock across Eastern, Central, Mountain, and Pacific time. The gap durations, wildly inconsistent, from 22 minutes at the shortest station to just over 16 hours at the longest, ruling out a single fixed-length event acting on all 7 the same way. The power logs, continuous voltage through every gap, no battery drop recorded at any station at any point. The hardware audit, 5 different camera models across the 7 units, 3 different card manufacturers, no shared firmware version linking more than 2 stations at once. The deployment log for each site, no scheduled maintenance, firmware update, or diagnostic check recorded anywhere near that date at any of the 7 locations, ruling out a coordinated software rollout as the explanation, and the surrounding frames on either side of each gap. No motion blur, no partial trigger, no sign of a mechanical fault beginning or ending gradually. Every gap starts and stops cleanly, like a switch rather than a failure. And nights like this one, a pattern buried across months of unrelated retrievals before anyone thinks to run the comparison, surface out of large standardized survey networks more often than most people watching this would expect. Subscribing with notifications on is the only way to know when the next one gets reviewed and released. Now, back to that ridge in North Carolina. No formal investigation followed because a data platform built to catalog wildlife detections isn't equipped to investigate its own equipment anomalies. What followed instead was an informal comparison against the rest of that year's uploads of the roughly 260 other arrays reporting data for 2024. None of the others logged a comparable multi-station, same local hour gap on any other night that year, and no other night in the platform's 5 years of operation produced a cluster this tight. The closest thing to an official record on the underlying storm comes from NOAA's Space Weather Prediction Center, and its findings are precise about what the Gannon storm did and did not affect. The center's own reporting, along with the peer-reviewed studies that followed, documents GNSS signal degradation, high-frequency radio interruptions, and geomagnetically induced currents on power infrastructure, measured, well-instrumented effects on systems built to receive satellite signals or carry current over long distances. No federal space weather agency has published findings connecting a G5 storm to interference in standalone, battery-powered, non-networked field equipment of the kind these 7 cameras are, and none has been asked to, since nobody outside this specific review has connected the 2 records. That silence in the literature accounts for why nobody flagged this pattern as storm-related in real time. It does not account for why 7 cameras in 4 time zones, with nothing electronically in common, opened gaps within 8 minutes of each other on local clocks the same night that storm peaked. One point about this file requires complete transparency, stated exactly where it belongs and not folded into a footnote. Camera trap technicians on several unrelated projects have described, informally, isolated incidents of unexplained recording gaps coinciding with strong aurora activity in past years, never compiled into any published dataset, never submitted for peer review, circulating only as anecdotes exchanged between field staff who've noticed the same kind of coincidence more than once across different projects and different equipment. That pattern has never been officially confirmed by any research institution, and it deserves to be weighed exactly that way. As an unconfirmed field observation passed between people who service this kind of equipment for a living, not as established science. Attached to any other night on the calendar, 7 scattered equipment gaps wouldn't survive a second look. But this particular night already carried a documented event into the review. Between May 7th and May 11th, 2024, NOAA tracked 8 X-class solar flares and at least 7 Earth-directed coronal mass ejections from a single sunspot region 17 times the width of Earth, designated AR 3664 by solar observatories. On May 10th, at roughly 12:30 p.m. Universal Time, the first of those CMEs reached the planet. Between 1:50 and 2:30 Universal Time on May 11th, ground stations across the American sector recorded the most extreme geomagnetic field perturbations of the entire event. The exact window, translated across 4 time zones, that these 7 cameras stopped recording in. A night that produces the most powerful space weather event in 20 years, and the same night 7 pieces of unrelated field equipment across 4 time zones stop working within the same 8-minute window of local time, stops reading as 2 unconnected facts sitting next to each other on a calendar. It starts reading like 2 records of the same night that were never designed to talk to each other, and only did because somebody happened to check. That overlap is not a one-time event confined to 2024. Solar physicists tracking the current cycle have stated publicly that comparable storm activity should be expected again in the coming seasons as the sun approaches and passes solar maximum, meaning the conditions that produce this specific overlap are not a historical curiosity. They are a recurring feature of the same monitoring network moving forward, with the next comparable storm potentially only months or years away, rather than decades. Set against the network's own 5-year operating history, an 8-minute clustering across 7 independent stations is not the kind of thing background noise produces. Roughly 260 arrays reporting for a single season, each running continuously for months at a time, generate thousands of individual recording gaps in an ordinary year for entirely mundane reasons: dead batteries, wildlife interference, weather, simple hardware failure. None of those ordinary causes cluster by local clock time across time zones. They cluster, if at all, around obvious shared triggers like a specific storm front or a specific firmware version, and this event matches neither. Large-scale standardized data networks elsewhere have documented similar cross-site anomalies that outlive their first explanation. Seismic monitoring networks, which rely on precisely synchronized independent stations for their entire scientific value, have occasionally logged simultaneous instrument disturbances during major space weather events that took researchers months to distinguish from genuine ground motion, precisely because the timing overlap looked too exact to be coincidence and too imprecise to be a single clean cause traceable to one shared mechanism. The architecture is the same: independent, precisely timed instruments, a real space weather event on the calendar, and a pattern that fits the timing without fitting the known physics of the instruments involved. Nothing that follows is established as fact. It is the only account these 7 logs and the storm record around them actually support, and no more than that. One reading of the file places it like this: something in the shared environmental conditions of that specific night. Not a signal, not a current, but some property of the atmosphere or geomagnetic field common to all 7 sites regardless of longitude, interacted with a sensor or clock component common to this camera model's design, producing a pause that reads on each unit's local clock rather than on any shared universal timestamp. That reading fits the data available in this file. It does not fit anything currently documented in the engineering literature for this hardware, and no manufacturer has been asked to weigh in on it. The physical record doesn't move once the theories are set aside. 7 stations, 4 time zones, gap opening times within 8 minutes of each other on local clocks. Continuous battery power through every gap. No shared hardware, no shared firmware, no scheduled maintenance anywhere near the date. None of it has been reconciled with NOAA's own technical account of what the Gannon storm actually touched. This channel does not claim the Gannon storm shut down 7 cameras, and it will not pretend NOAA's own published findings say that either. A single overlapping night is not a confirmed mechanism. What the record shows is what the record shows, and where the record stops, this account stops with it. Files like this one, a pattern that only exists because someone cross-referenced records nobody designed to be compared, surface out of large standardized networks more often than most people expect. And most of them start exactly the way this one did, as a routine metadata check that turned up something nobody was looking for. If you know of a case that belongs in this archive, the comments are usually where it starts. All 7 stations are still in the network, still running, still uploading to the same shared platform they always have. The next major storm on the solar cycle is still coming. The frame ends. The 7 clocks it stopped on all started again, and none of them agree on why.